On today's video, we're going to be talking more about complex numbers. What we're going to do is we're going to perform some operations, which is just addition, subtraction, and multiplication, and then on the next page we'll do division. So when you're doing addition and subtraction, all you have to do is combine like terms, and if you have a radical, make sure you simplify them first. So i's can be just treated like a variable. So if you have 2 plus 4i, that's a complex number, and then you're adding to it the complex number negative 4 plus 6i, all you have to do is add the real terms together, 2 plus negative 4, which is negative 2, the real plus the real, and then add the 4i and the 6i. 4i plus 6i is 10i, and that's it. It's pretty easy. Subtraction, be careful with subtraction because this subtraction goes to both of those terms and it negates each one of these. So you'll have a negative 3 minus 6. Negative 3 minus 6 is negative 9. And negative 4i minus a negative 8i is like negative 4i plus 8i. Negative 4i plus 8i is equal to a positive 4i. So addition, subtraction, just combine like terms. If you have a radical like the square root of negative 9, remember that is becoming an I on the outside. This is becoming an I on the outside. The square root of 9 is 3, so this is just 4 plus 3i. And you're going to subtract from that. The square root of 25 is 5, so that just becomes a 5i. So what you're going to do is, well, 4 doesn't have anything to subtract from over there, so it's just going to become a 4. And 3i minus 5i is negative 2i. And in this one, the square root of negative 8, remember negatives become imaginaries in both spots. The square root of 8, break it down into 4 times 2, take the square root of 4, and that becomes 2i square root of 2. So you have 2 minus 2i square root of 2, and you're going to add to that a negative 4, and then this 32 breaks up into 16 times 2. The square root of 16 is 4, and 4 times 2 is 8, so you're going to add to that 8. Don't forget the I, and then you're left with the square root of 2. So you have like terms here. You have 2 plus negative 4, which is negative 2, negative 2i square root of 2, positive 8i square root of 2 will give you a positive 6i square root of 2, like terms combine. Now when you multiply two complex numbers, you're going to be using the FOIL process. FOIL, two binomials. So when you have a complex number times a complex number, this is two binomials, which is a FOIL. But up here, if you have any power of I, like if you have I squared, which you're going to see a lot, I squared always has to change into a negative 1. Never leave an exponent on an I. So when you FOIL this, 2 times negative 4, 2 times 6i, which is a positive 12i, 4i times negative 4, and 4i times 6i. 4 times 6 is 24. I times I is I squared. Always when you're doing the last two terms, you are going to end up with an I squared in it because you'll have I times I, which is I squared. So what you're going to do is you're going to combine these two together. 12i minus 16i is a negative 4i. And I'm going to drop this negative 8 down here. And 24i squared is 24 times, this is times I squared, and I squared is negative 1. 24 times negative 1 is negative 24. So you have negative 8 minus 4i minus 24. Negative 8 minus 24 is negative 32. And then the 4i doesn't combine with anything else. So you just keep it like that. The next example, FOIL, 6 times 6, 36. 6 times negative 3i, negative 6 times 3 is 18i. 3i times 6, positive 18i. 3i times negative 3i. Positive times negative is negative. 3 times 3 is 9. I times I is I squared. These two combine, but negative 18i, positive 18i just turn into a 0. So that they actually cancel out. So what you're left with here is 36 minus 9 times negative 1. This minus 9 times I squared, which is a negative 1, turns into negative times negative is positive. So what this turns into is this 36 minus a negative 9 is plus 9. 36 plus 9 is 45. So this answer is just 45. There is no imaginary part. On this one, we have to foil, and then combine like terms. So let's foil the first. 3 times 1 is 3, plus 6i, minus 2i squared. I squared is negative 1. Negative 2 times negative 1 is positive 2, so 3 plus 2 is 5. 6i minus I is 5i. So what you have in the first one is 5 plus 5i. In the second one, when you FOIL this, 1 times 2 is 2, plus 1 times I, minus 2 times I. Negative times positive is negative. I times I is I squared. I squared is negative 1, so a negative 1 is a positive 1, and 2 plus 1 is 3. I minus 2i is negative I. So that FOILed out becomes 3 minus I. And then when you add them together, 5 plus 3 is 8. 5i minus I is 4i, and that would be your final solution. On this next one, we're going to have to distribute the 3i squared into all of the terms here. So let's start. 3i squared. 3 times 3 is 9. I squared times I to the fourth. When you multiply, you're adding the exponents. 4 plus 2 is 6. 3 times 5 is 15. I squared times I cubed is I to the 2 plus 3 is 5. The next one is positive. 3 times 2 is 6. I squared times I squared is I to the fourth. The next one, 3 times negative 6 is negative 18. I squared times I is I to the third. And the last one, negative 5 times 3 is negative 15. I squared. So all of these have powers of I. And if you remember from the previous page, you just divide the exponents by 2 and note the remainder. Well, if you remember, I to the 6 has a remainder of 2, which is I squared, which is negative 1. So I to the 6 always turns into a negative 1. So this is 9 times negative 1. 15. I to the 5th turns into an I. I to the 4th turns into 1. I to the 3rd turns into negative I, and I squared turns into negative 1. So now what we have is negative 9 plus 15I plus 6 minus a negative is positive 18I, and minus a negative 15 is plus 15. So now we're going to just combine like terms. Negative 9 plus 6 is negative 3. Negative 3 plus 15 is 12. 15i plus 18i, add them together, and I think you get 33i. And I think that's the right answer. I'm hoping. If I made a mistake, somebody please tell me. The next one is a FOIL. F-O-I-L. 3 times 1 is 3. 3 times 2 square root of negative 18. Oh, that negative's got to come out and become an I. So 3 times 2i negative is negative 6i square root of 18. This negative comes out and becomes an I. I square root of 8 times 1 is I square root of 8. And I times 2i. The last I times 2i is 2i squared. Positive times negative is negative. So negative 2i squared. And then 18 times 8. Let's see what 18 times 8 is. 144. So FOIL here. Now we have to break this up. 18 is 9 times 2. 8 is 4 times 2. So this becomes 3 minus. The square root of 9 is 3, and 3 times 6 is 18. I square root of 2. The square root of 4 is 2. That becomes 2i square root of 2. I squared is negative 1. So this is minus 2 times minus 1, which is a positive 2. Negative 2 times negative 1 is positive 2. And the square root of 144 is 12. 2 times 12 is 14. 14? No, it's 24. So now we have the combining of like terms. 3 plus 24 is 27. Negative 18i square root of 2, positive 2i square root of 2 becomes negative 16i square root of 2. That is a tough problem. And then the last one, 5 minus 3i times 5 minus 3i is a FOIL, F-O-I-L. When you square it, remember you have to FOIL. So 25 minus 15i minus 15i, 3 times 3 is 9, I times I is I squared, and negative times negative is positive. Remember, I squared is negative 1, so this becomes a negative 9. So we have 25, negative 15 and negative 15 is negative 30, and 9 times negative 1 is negative 9. 25 minus 9 is 16, so we have 16 minus 30i for the final answer of that one. Now division is a little bit harder because I is a radical. Remember, I is the square root of negative 1. So the square root of negative 1 is in the denominator, and we can't have a radical in the denominator. It needs to be rationalized. So when you have an I in the denominator, if it's a monomial means it just has one term. Those are monomials. These next ones are binomials. Monomials just have to be multiplied by I over I. Because what you get here is when you multiply 7 minus 2i times I, you get 7 times I. Negative 2i times I is negative 2i squared, and in the denominator I times I is I squared, and we always turn I squared into negative 1. So this becomes 7 negative 2 times negative 1, 7i. Negative 2 times negative 1 is positive 2. I squared is negative 1. So usually when you divide something by negative 1, we're going to turn all those terms into the opposites. So this is negative 7i minus 2. Both of those terms get negated. On this second example, you're going to multiply by I over I. Not 5i, but just plain old I. 4 times I is 4i. Negative 6i times I is negative 6i squared. 5i times I is 5i squared. I squared gets turned into negative 1, so the 4i stays a 4i. A negative 6 times a negative 1 is a positive 6, and 5 times negative 1 is negative 5. And that can't be reduced, so we're going to leave it like that. Now this is a binomial, so you have to multiply by the conjugate of the denominator. So you're going to multiply by 2 minus 3i over 2 minus 3i. And when you multiply the tops, you have to FOIL. And the bottoms, you only have to do F and L. So when we FOIL this out, 1 times 2, 1 times negative 3i, 2i times 2, 2i times negative 3i is negative 6i squared. And on the bottom, 2 times 2 is 4. Negative times positive is negative. 3i times 3i is 9i squared. So now we have a negative 6 times a negative 1, which becomes a positive 6. 2 plus 6 is 8. Negative 3i plus 4i is positive 1i. And on the bottom, 4 minus a negative 9. Remember, 9i squared is negative 9. 4 minus a negative 9 is 4 plus 9, which is 13. This next one, the conjugate of the denominator is 7 minus I. Oops, 7 minus I. So you have to FOIL the top. You have to F and L the bottom. So 7 times 7 is 49. 7 times negative I. 7 times negative I. And negative I times negative I is positive I squared. And on the bottom, 7 times 7 is 49. Negative times positive is negative. I times I is I squared. Turn those I squareds into negative 1. And you have 49 minus 1, which is 48. Negative 7 minus 7 is negative 14i. And 49 minus a negative 1 is 49 plus 1, which is 50. Now when you reduce these, you can reduce them if everything will divide out by 50, or if they have a common factor. So what we have is 48 over 50, which reduces, minus 14i over 50, which also reduces. So what we have in the final answer is divide both by 2 and you get 24 over 25. Divide both of those by 2 and you get 7i over 25. So you can leave the answer like that. The square root of negative 25 is 5i. The square root of negative 16 is 4i. So 2 plus 5i, 1 minus 4i. You're going to multiply by the conjugate of the denominator, which is 1 plus 4i. You're going to have to FOIL. And 2 times 1 is 2. Plus 2 times 4i is 8i. 5i times 1 is 5i. And 5i times 4i is 20i squared. And in the bottom, 1 times 1 is 1. Negative 4i times positive 4i is negative 16i squared. And then the I squareds turn into negative 1s, so this becomes a negative 20. Negative 16 is positive 16. So what you get is 2 minus 20, which is negative 18. 8i plus 5i is 13i, and 1 plus 16 is 17. And you can split that up if you want to. Negative 18 over 17 plus 13i over 17. It's probably a good idea to split those up. Like this one, you should probably split this one up here into 8 over 13 plus I over 13. So you can have a real part and an imaginary part. And then this next one, the square root of negative 144 is 12i. The square root of negative 1 is just 1i. So we have 4 minus I. We have to multiply it by the conjugate, which is 4 plus I. 4 plus I. So when you FOIL the top, 3 times 4 is 12. 3 times I is 3i. 12i times 4 is 48i, and 12i times I is 12i squared. On the bottom, 4 times 4 is 16. Negative times positive I is negative I squared. Turn all those I squareds into negative 1, so this becomes a negative 12. 16 minus I squared is plus 1. So you have 12 minus 12, which is 0. 3i plus 48i, 3 and 48 is 51i, all over 16 plus 1, which is 17. And I think 51 divided by 17 is 3. Yeah, 51 over 17 is 3, so this is just 3i is your final answer. Here's a vocabulary word for you. A multiplicative inverse of any expression is just 1 over that expression. It's just a reciprocal. So sometimes we're asked to find the multiplicative inverse of a complex number. So if we want to find the multiplicative inverse of this, it's just 1 over that. But you can't have an I in the denominator because it's a radical, so you have to multiply it by the conjugate, 2 minus 4i over 2 minus 4i. And what you get is 1 times 2 minus 4i, which is just 2 minus 4i. And on the bottom, 2 times 2 is 4. 4i times negative 4i is negative 16i squared. A negative 16i squared is a positive 16. So you have 2 minus 4i over 4 plus 16, which is 20. And then we're going to split this up into two fractions, 2 over 20 minus 4i over 20. And then 2 over 20 reduces to 1 over 10. 4i over 20 reduces down to 1i over 5. And so that's the multiplicative inverse of that. And one more, let's do the multiplicative inverse of 8 minus 4i, which is just 1 over 8 minus 4i, multiplied by the conjugate of the denominator. 1 times 8 plus 4i is 8 plus 4i. On the bottom, 8 times 8 is 64. Negative times positive is negative. 4 times 4 is 16i squared. This becomes a positive 16, so we have 8 plus 4i all over 64 plus 16, which I believe is 80. So we're going to split this up into two fractions. We have 8 over 80 plus 4i over 80. 8 over 80 reduces down to 1/10. 4 over 80 reduces down to 1 over 20, so you have I over 20. So there's your multiplicative inverse of that. And that's it for today. We get to practice this a lot tomorrow. Have a good night.